In this video, I'm going to be covering question 2, part A from the 2019 AP Calculus AB Free Response Calculator Required portion of the test. I cover A, B, C, and D all in their own individual videos, so if you want to see those solutions, feel free to check out my other videos. So on A here, they're just asking us to justify why there must be at least one time in between these two values here, such that the derivative of our velocity equation, which is also known as the acceleration equation, has to equal 0. So whenever you need to justify and show that a derivative equals a certain value, 99 times out of 100, that's going to be the mean value theorem that they want you to go through. And so the mean value theorem, the first thing you always have to do is make sure that you fit the requirements of the mean value theorem. The mean value theorem, in order to use it, requires that your function is first and foremost continuous on whatever that interval is, on the closed interval that they're talking about. And the second thing they want you to do is they want you to tell them that it's also differentiable on that open interval from A to B. So we would want to check and make sure our function does that. So looking back at the language of the problem, they're telling us the velocity of particle P is given by the differentiable function v of p right here. So because it tells us it's differentiable, we know that it's going to be differentiable on our interval here. And it's also, because it's differentiable, inside being differentiable in order to be differentiable, it must be continuous. That's one of the requirements of something being differentiable. And so because it's differentiable, we also know that this function is going to be continuous on that interval from A to B. So to start off on this, what you would want to do is you would want to tell them your original function, not what you're finding the derivative of, but the original function, v sub p of t, you would say is differentiable and continuous on the interval they're talking about. So on the interval from 0.3 to 2.8. Therefore, the mean value theorem, I'm just going to call it MVT, the mean value theorem applies. And so what do we get out of the mean value theorem? Well, the mean value theorem tells us that if it applies, then the average rate of change, f of b minus f of a, over b minus a, the average rate of change, I'm just going to call that the AROC, has to equal the derivative, the instantaneous rate of change at some point c. Well, how convenient. What we want to do is we want to show them here that our derivative, the v prime sub p sub t, that needs to equal 0. Well, to do that, what we're going to want to show them that at some point this average rate of change was equal to 0. So to make this equal to 0, what you want to do is you want to look really at the top part here. These are our y values. That's really y2 minus y1 going on up top there. So you want to look at your table and see, do I have two places where the y value is the same? Sure enough, 55 and 55 are happening conveniently at the x values we cared about, which are 0.3 and 2.8, the endpoints, the a value and the b value that we were talking about in that definition. So what we then say is that 55 minus 55 over 2.8 minus 0.3, we know that that equals 0. And since that equals 0, we know by the mean value theorem that some point in between here has to have a derivative value of 0. And so that would be our final conclusion. We would tell them that we ended up getting out 0 for our average rate of change. And because of that, by the mean value theorem, we know that there's some point t that has to live in that little interval. And so we've now justified what they wanted us to justify. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.